Okay, so we are gonna complete this question. We've got two masses on an inclined, doubly inclined hill, and we are gonna try to solve this in the following situation. All right, people, let's go. Calm down. Here we go. First things first. Our FBD, FN, FN, FG, FGY, FGX. Now our FGX, of course, is parallel to our surface. And now we're going to make the assumption that by the way, we're live, right? All right, here we go. So, this is my FBD. This is what it's going to look like. Hold. And to the assumption that we're going to make is that my mass, this mass right here, is causing my motion. And you're probably looking to see why is this mass causing the motion. Firstly, it's the larger mass, number one. Number two, this angle is a steeper angle. So my assumption is based on the mass and the angle, and therefore I'm saying that it's going to go this way. Okay? Larger mass, larger angle. So to break this down, this is what we need to do. So our system's equation is going to be the following. Now what's causing my object to be moving forward this way? So this is going to be this FGX right here. So I'm going to say FGX2 or FG2X minus what is pulling back on the other side, FT, minus FK2, which equals to mass 2 times acceleration. Okay? And this one right here, what's pulling me forward? Well, it's going to be FT. Minus what's pulling me downward, FGX1 minus FK1, which equals to mass 1 times acceleration. Okay? Now, of course, your FT and FT are going to cancel out. So you're left with FG2X minus FK2 minus FG1X minus FK1, which equals to mass 1 times acceleration plus mass 2 times acceleration. So as you could see, this is not a very good looking equation, but it's the correct equation. Okay. All right. So there is one place that I know most likely you make that mistake. And your mistake is going to be as follows. So when we go to calculate FK2 and FK1, this is what you're going to do. So to find out your mu k, it's going to be mu k equals to fk divided by f1, fn. Okay? And this is fk1 or fk2, it doesn't matter. Let's do the following. So you have mu k times fn, which equals to fk2. Now what is fn? From our diagram, we know that fn is going to be fgy. So you're going to write down as fk2, which equals to 0.21 times FGY. So far so good. This is where most likely your mistakes probably happened. Okay, because most people forget to take into account that Fn is not Fg, it's Fgy. So you're going to do it again, Fk2, which equals to 0.21 times mass, which is 12 kilos, times 9.8, times the cos of 39. What do you get for Fk2? 14.39, 14.3 newtons. Now we're going to do the exact same thing for Fk1. Okay, so write it down again. Fk1, 19.2. So 19.2. Okay, so Fk1 is the same thing, 0.21 times a mass of 8 times 9.8 times the cos of 26. And Fk1 comes out to 14.3. Now, this is another mistake where people most likely make mistakes, and that mistake right here is that they forget to put 9.8. They'll do 0.21 times 12 and they forget 9.8. Okay? Yes. 14.8. 14.8. 14.8. All right? So we're going to go back to this equation right here and try to solve for it. And my equation is going to look like this. So let's erase that. All right. So we're going to go back here and it's going to be Fg2x. And of course, Fg2x is made up of m2g sine of 39 minus Fk2, which was 19.2, minus Fg1x, which is m1g sine of 26, minus 14.8 divided by 12 plus 8, which equals to your acceleration. So m2g, of course, was 12 times 9.8 times sine of 39 minus 19.2 minus 8 times 9.8 times sine of 26 minus 14.8 divided by 20, which gives you your acceleration. What is your acceleration? Yeah. 0.25 meters per second squared. Does this make sense? But you could see how, because of our kinetic friction, our equation, we have to really make sure we do not forget our kinetic friction, that we're not just assuming it's Fn equals to Fg. Questions, concerns, issues? This is a very similar to a test question. Most of the test questions are going to be similar to what you've just seen. Any other questions, concerns? Are we good with this? Yes. 0.28. .28 meters per second squared. Are we good? All right. Okay, so this is question number 5 from page 89 in the new textbook. We have a mass that's given 39 kg, a tension that is not given. We are just given an angle of 21 degrees. We have the x. We haven't been given, of course, the x component or the y component. We're given mu k, and we are given that the object is moving at a constant velocity. We are trying to figure out what the tension in that rope is going to be. And the best way to complete this question is as follows. So, of course, we know that the net force of this object is going to be 0, and the reason being because the object is moving at a constant velocity. So acceleration is 0, F net x is 0, F net y is 0. So if we're looking at the x direction, my F net X is going to have the following two forces, or a few forces that are going to make this up. It's going to be FTX minus Fk, which equals to mass times acceleration. Okay, now of course mass times acceleration is 0, so this goes to 0. So therefore, your FTX equals to your Fk. Okay, and FTX of course is Ft cos of 21, which equals to Fk. Now we don't know what Fk is. So to calculate my Fk, I'm going to look at it in terms of my y direction. So F net y equals to 0 as well. Okay, and in the y direction, well, I've got 1, 2, and 3 components to that force. So it's going to be Fn, which is going upward, plus Fty, which is going upward, minus Fg, which is going downward, which equals to 0. Okay. Now to get my Fn, what I need to do is, of course, move my other two forces. So Fn equals to Fg minus Fty. So Fg is mass times gravity, 39 times 9.8, minus Ft, and this is going to be sine of 21. Sine of 21 degrees. Now, what we're going to do next is try to figure out what our mu k is, and hopefully we are able to solve it from the mu k. Okay, so what we'll do is we will take a look at mu k, which equals to Fk divided by Fn. Okay, and it's going to be mu k times Fn, which equals to Fk. Okay, and that's going to be 0.23 times this whole thing right here. By the way, can you tell me what 39 minus 98 is? Oh, sorry, 39 times 9.8. So this is 382.2 minus Ft sine of 21. This is your Fk. Does that make sense? So what we've done is we've taken mu k and multiplied it by this whole statement right here. So we go back to this equation right here. We go back to this equation, and we're going to work with that equation now to solve for this problem. Okay? Can I erase the top part of it? Okay. So, now to solve for this problem, okay, so what we're going to do is we're going to say Ft cos of 21, which equals to 0.23 times 382.2 minus Ft sine of 21. Okay? All right, can we multiply 0.23 with these two? So you end up with Ft cos of 21, which equals to, what's 0.23 times 382.2? What is it? 87.91 minus 0.23 times Ft sine of 21. Okay, bring this over to the other side, so you get Ft cos of 21 plus 0.23 times Ft sine of 21, which equals to 87.91. Now we're going to factor out Ft, so you got Ft, which Ft times cos of 21 plus 0.23 Ft sine of 21, which equals to 87.9. See that again? We're factoring it out. Yeah, but that 0.23 is going to stay here. So yeah, we're going to take off the FT. That's correct.